Good morning to sirs and madams of Emertxe Information Technologies. I am Pallavi studying BTech in ECE and Communication Engineering at Vagdevi College of Engineering, Warangal, Telangana. I am really fortunate to do this IoT internship at Emertxe Institute. In this online IoT internship, I have learned many new things and I have successfully completed the project on IoT based home automation solutions as alone by attending the online classes and listening through the recorded sessions in LMS. In this internship, I have learned C programming, C++ language, introduction to IoT, introduction to embedded systems, introduction to project and its requirements, programming LED, CLCD, ADC, temperature sensor, PWM, serial tank, controlling LED using LDR, blink app configuration. It controls devices like heater, cooler, serial tank through Blink cloud server and display notifications. Coming to C programming, C language is powerful, efficient, flexible, deep. We can explore our system. C important characteristics are it is a general purpose language even though it is applied and used effectively in various specific domains. It is a free formatted language. Efficiency and portability are the important considerations. Library facilities play an important role. C language is used in system software development, embedded software development, OS kernel development, firmware, middleware, and driver development, file system development, and many more. C language consists of data types, conditional construct, operators, arrays, pointers, recursion constant qualifiers, strings, storage classes, preprocessors, and UDT. C keywords categories data types, modifiers, qualifiers, loops, jump, decision, storage class, derived, user defined, and others. These are the keywords that we are used while programming in C. Typical C code contains documentation, preprocessor statements, global declaration, the main code. In main code, local declarations, program statements, function calls, one or many functions, the function body. This is the example of C language program for Hello World. C++ language. C++ is a statically typed, compiled, general-purpose, case-sensitive programming language that supports procedural, object-oriented, and generic programming. It adds many features to the C language and is perhaps best thought of as a superset of C. C++ language consists of class, object, access specifiers, modifiers, constructors, and destructors. C versus C++ language. C++ is mainly object-oriented programming language while C is procedural-oriented programming language. In C, program is divided into small chunks based on the functions. In C++, program is divided into objects depending on the problem. Each function contains different data in C. Each object controls its own data in C++. follows a systematic approach to solve the problem in C, focuses on security of data irrespective of the algorithm in C++. In C, no easy way for data hiding. In C++, data hiding is possible in OOP. When compared to C++, C is a subset of C++. C++ is a superset of C. C++ can run most of the C code while C cannot run C++ code. C supports procedural programming paradigm for code development. C++ supports both procedural and object-oriented programming paradigm. Therefore, C++ is also called a hybrid language. C does not have namespace feature. C++ uses namespace which avoid name collisions. C does not allow functions to be defined inside structures. In C++, function can be used inside the structure. C has no support for virtual and friend functions. C++ supports virtual and friend functions. These are the comparison between C and C++ languages. Applications of C++. If you need high performance and precise control over memory and other hardware resources, then C++ would be nice choice. Few applications of C++ are video games, high performance financial application, graphical application and simulation, productivity office tool, embedded and real-time software, audio and video processing. Coming to Introduction to IoT, Internet of Things is abbreviated as IoT. The definition of IoT is the network of physical objects that contain embedded technology to communicate and interact with their internal states and or the external environment. Unique objects are connected to internet. Devices are connected, not the people. It is bidirectional communication. It is large, complex data flows. It is new types of insight. Applications of IoT. From home to at workplace, we are using many applications through IoT. Like we use IoT in alarm clock, refrigerator, automobile, Vivo IP phone, computer, printer, media player, microwave, coffee maker, smart scale oven, cell phone, vending, security, televisions to control these appliances. Internet of Things. It is the reference architecture of IoT, like device connectivity, data processing and analytics, presentation. Coming to Introduction to Embedded System, we have many definitions for embedded system. One of the definition is any combination of hardware and software which is intended to do a specific task can be called as an embedded system. Embedded system categories are stand-alone, real-time, networked, and mobile. Examples. These are the examples of embedded system. They are microwave oven, washing machine, television, CC camera, refrigerators, car, robotics, aeroplane, MRI scannings, CD drives, Wi-Fi routers, missiles, mobile phones, and etc. Components. These are the components of embedded system. Basically, embedded system consists of input, output, microprocessor or microcontroller, or we can say it as system on chip, and other peripherals like software, digital to analog to digital converters, diagnostic ports, actuators, sensors, auxiliary system, human interface, memories, FPGA or ASIC software like we see in the slide. Coming to introduction to project and its requirements, the project title is IoT based home automation solutions. The home automation is able to control the lights, temperature of the home, inflow and outflow of water in that water tank. It is simulated on the PixSim simulator. Blink IoT mobile applications used to control the devices. This project requirements are the Arduino IDE, PixSim Lab Simulator, Null Emulator, Blink IoT mobile application. It is the hardware Arduino Uno hardware board. It has pin configuration. Arduino IDE software tool. In this, we can write the program and we compile it and burn it on the PixSim Lab simulator. Here it is a PixSim Lab simulator. The code is dumped into this simulator and output is seen by some of the spare parts connected to it. Arduino requirements are LED, temperature system, ADC, LDR, light dependent resistor, serial tank. It uses serial communication, Ethernet shield, Blink IoT app, LEDs, light emitting diodes. Simplest device used in most on the embedded applications as feedback. Works just like diodes. Low energy consumption, longer life, smaller size, fast switching, make it usable in wide application fields like home lighting, remote controls, surveillance. CLCD character liquid crystal display. Most commonly used display ASCII characters. Some customizations in symbol possible. Communication modes are in 8-bit mode and 4-bit mode. Analog inputs. Analog to digital converter. It's pulse width modulation. Very important peripheral in embedded systems for real-time activities. The controller understands only digital signals, so and real-time linear signals have to be converted into digital form. It is multiplexed with general purpose input and output. Comes with different architecture like SAR is the most commonly used. Here SAR stands for Successive Approximation Register. LDR, Light Dependent Resistor, reads the LDR sensor value based on the reading from LDR, vary the brightness of LED, which resembles controlling garden lights based on the availability of sunlight. So in the daytime, the light will get off by this sensor, and at the night time, in the absence of sunlight, the light glow by sensing the LDR using LDR. So LDR senses and give information to the Arduino Uno, and it turns off and on the lights. Temperature control system. The temperature control system consists of a heater resistor and LM35 temperature sensor and a cooler, which resembles the temperature control system at home. Reads the temperature from the temperature sensor LM35 and display it on the CLCD. Control the temperature of the system by turning on off the heater and cooler through the Blink IoT mobile app. Here CLC temperature system gives the information to Arduino Uno, and it goes to the Blink IoT, and the notification is reached to the CLCD through Arduino Uno, and CLCD displays the notification, and in the Blink IoT app also we can see notifications. Serial tank. It is for the serial communication. It reads the volume of water in the tank through serial communication and displays it on the CLCD. Controls the volume of the water in the tank by controlling the inlet and outlet valve by sending commands through serial communication. Displays the volume of water in the tank on the CLCD. Null emulator is required for the serial communication. It provides COM1, COM2 pairs. By these COM pairs, we can communicate to serial tank for the Arduino Uno. Blink IoT app. Blink is a full set of software required to prototype, deploy, and remotely manage connected electronic devices at any scale, from personal IoT projects to millions of commercial connected projects. With Blink IoT, anyone can connect their hardware to the cloud and build a no-code iOS, Android, and web applications to analyze real-time and historical data coming from devices, controls them remotely from anywhere in the world, receive important notifications, and much more. Blink was designed for the Internet of Things. It can control hardware remotely, it can display sensor data, it can store data, visualize it, and do many more cool things. It creates widgets on mobile Blink application. Button widgets to control heater, cooler, inlet valve, outlet valve. Gauge widgets to display temperature and volume of the water in the tank on the mobile application. Terminal widgets to display the notifications whenever threshold is crossed, like temperature is more than 35 degrees. Turn off the heater. Water level is full. Water inflow is disabled. IoT based home automation solutions. It is used. Here we can see that home appliances like lighting, garden lights, like those are mobile home appliances are controlled using Pixim Lab device. It is connected to Blink app that is installed in our mobiles, so we can control with our mobile app Blink our home appliances through the cloud server. This is a project code. Now we will see oral presentation. This is my project code, home automation Blink control. Here we include many files other files like ler.cpp. It is a C++ language file. It is ler.h. It is a header file. It is main.h file. It is serialtank.cpp file. Serialtank.h file. Temperature sensor.cpp file. Temperature system.h file. By using this LDR, serial tank, temperature system and main.h and home automation blink control files, we are going to implement the project. Now I am saving the project code. It is done saving. Then go to compilation, compile it. Done compilation successfully. Now we go to sketch and export compile library. Then we have to go to PiximLab simulator. Here we have in the file we have to load hex file, that is in the home automation blink control file. Open it. It is loaded and go to spare parts. Choose serial tank. Now I am controlling the light, LED light to the LDR, light dependent resistor. As we are decreasing, then the light goes off. As we are increasing the LDR value, the light ons. Then as we are on the cooler, here we are seeing that cooler is running. Now we are offered, then fan stopped off. Heater is on and we are displaying heater on the CLCD, and it is get off when reached 35 degrees, and we are viewing the temperature is above 35 degrees Celsius, turning off the heater. Now we are in tab 2, outlet valve. Outlet valve is on and tank is started flowing water outside. Now we are seeing the tank gets filled and inlet valve is on. Automatically, after filling the tank, inlet valve get off, and we are view notifications in the mobile app that water level is less than 2000, water inflow is enabled. Water level is full, water inflow is disabled. Thus, we see the notifications in the Blink IoT app. Here we can see the tank is getting low and automatically it is filling when it reaches below 2000 liters water level. This is my project. Thank you.